So the platform is also scalable. Now we designed the platform originally because we were thinking about cost before the 4K chip came out. Okay, so we designed it with 0.98 inch chips. So with this 0.98 inch chip, we've determined that we can get up to 40,000 lumens with this engine. Okay, just keep adding lasers until you hit 40,000. Now, if you decide that you need to be on the 1.2 inch chip or the 4K chip, then the chip gets bigger, this thing goes up, you can probably get up to 80,000 lumens on it. Okay? So, depending upon how the commercialization partners want to move forward, and I'm sure you guys will be telling them, what you'd like out of this, the smaller chip or the bigger chip has an impact. Like the drive-in theater guys would love to have, the 80,000 lumens. Okay? For the average theater, it's not necessary, and in fact, 22,000 lumens or 25,000 lumens is probably plenty.
When you're talking about this really concentrated light, the DMD can still sustain that many lumens without burning up the DMD.
Yeah, so we haven't actually run the DMD at 80,000 lumens, okay? But one of the things that is an advantage here is we don't have IR, okay, with these lasers. So there's no IR in the system, there's no UV in the system. It's only the narrow wavelength is actually usable light. So aside from the absorption at that spectrum, there's no extra heat that's generated. So currently in our engine at 11,000 lumens, the DLP chillers don't turn on at all. Okay.
What kind of cooling do you have on your chip? Is it liquid or is it
right
air?
now we have what's standard in a conventional projector. We literally pulled it out of an existing projector and put it in, which is a liquid. And there's also Peltier, TEC cooler on this module. The TECs don't turn on. Okay, we don't need them to turn on. And in fact, I'm recommending to the commercialization partners that they're gone. Okay, because they're not reliable and expensive and a problem. You don't need them. Okay. So, there's going to be some changes and some savings again there. There's some other cooling parameters that can be redesigned in the system to further cut the costs of that loop around the DLPs. Yeah.
You mentioned getting FDA approval. Do you see any shelf occurring with FDA on a certain lumen brightness, anything like that?
We've done, so I'll be covering that in a minute. We've done internal safety analysis, and we've also hired an external consultant to do his own. And we've determined that the projector is equivalent to xenon, and that you're safe within up to 40,000 lumens. You're safe within a few feet of the projector. Okay, literally, so the FDA's got no problem in a booth whatsoever, the booth scenario whatsoever.
You're talking about looking in the lens up to a few feet.
It's just like a regular xenon projector. I mean, literally just like it. What you wouldn't do with a xenon projector, you wouldn't do with this, and your eye responds exactly the same way. So in other words, there's a they call it 3BR or something like that. R is within the time of your eye response. So if you get into a situation where you're seeing a bright light, your eye responds by moving away, and you're safe again. And so there's those criteria. But we have the variances should be set by the FDA, and they've given us verbal approval. So we expect to have the written approval very shortly.
In that same vein, is there any disposal issue at the end of life? I mean, or in some environmental issues that come into
So that's a good question, and we've done environmental studies on the projector, and basically mostly carbon footprint studies. But this is conventional electronics, so there's no substantial issue that we know about.
No mercury or anything.
What's that?
No mercury or anything in that laser.
No mercury. I mean, there are materials in there that folks are going to want to recover just because they're expensive. Like on circuit boards and things. I'm sure in the lasers, there's probably some materials in there that they're going to want to. There's definitely copper and things like that they're going to want to pull out of there. So I imagine, just like everything else, to grind it up and separate the materials. But it's nothing unconventional that is not used in production as today.